Hello everyone, let us now discuss today's LeetCode POTD problem, redundant connection. Here we are given with a tree, an undirected graph that is connected and has no cycles. Graph that has started as a tree with n nodes labeled from 1 to n with one additional edge added. How does this graph will be represented? A node here and another node like this. So these will not contain any cycles. A tree is an undirected graph that is connected and has no cycles, right? An added edge has two different vertices chosen from 1 to n and was not an edge that already existed. So this is the tree, but if I add a edge between two vertices, then it will become an additional edge for that graph. So if you see, the graph is represented as an array, edges of length n, where edges of I is equal to ai, and ai is connected with bi. We need to return the edge that can be removed so that the resulting graph is a tree of n nodes. If you see clearly, this is also called as a tree. But imagine there is an edge from here to here, then it will become a graph. That means it will not become a tree. So here we make a conclusion that this edge need to be written only when this is having a cycle. If I add this edge, so this will make a cycle if I add this edge. And here they clearly mentioned that a tree doesn't have any cycles. So if I take this example, the first example, I will construct the graph 1 and then an edge between 1 and 2. Now I have another one, 1, 2, 3. So 1, 2, 3 will be an edge. Now I have 2 and 3. If I take this edge 2 and 3, 2 is already present and 3 is present in my graph. But how do I know that? For that, I will start a search, either a BFS or a DFS from 2 and check whether I end at 3. If so, if I get a path from 2 to 3, then this is the edge that I need to be written. But wait, why I am telling that if I get a path from 2 to 3? Because imagine if this is the graph, imagine there is no edge between 1 and 3, then there is no cycle if I add edge between 2 and 3. So simply I can add. So if this is the graph, it is not a problem. So that's why I am checking whether there is a path from 2 to 3. Now, here another example 1 to 2, then I got from 2 to 3, then 3 to 4, and now 1 to 4. If you see, this edge is making a cycle because if I start with 1 and search for 4, I'll get a 4 here. So if I add an edge, this is the edge which is causing a cycle in this tree. So this is the answer I need to return. But wait, how do I approach for this problem? I'll start with two searching algorithms. First one, DFS. I start with the node which is given to me. Then I'll go by the left one or the neighbor and the next neighbor. I will traverse through all the neighbors if I am searching for a BFS. Now I got this neighbor. Now I will search for the next one, and here if I have a next one here, I will search for the next one. In the DFS, every node U and V which is given to me in the edges, I will do a depth first search from U to V. So if I got a V, then I will return this edge. So that's how this algorithm works. Now I get here, then I move here and here, then I'll move till here and then here. I go till the depth and backtrack in the searching algorithm. Let's first search algorithm. I will be using a queue. I am starting from here. I will search all the nodes which are having a breadth of 1. After that, I will search all the nodes which are having a length of 2. This is how the breadth first search algorithm works from U to V. If I search from U to V and I got a path, then this is the edge I need to return. In the DFS algorithm, I will start by creating a graph which includes node and their neighbors, right? If one is having the neighbors like 2, 3 and 4, this is the way the graph stores. How this DFS will work or the function will be discussed later. The main function or the function is redundant, right? Redundant function will go through every edge in the given edges. For every edge, u will be edge of 0 and v will be edge of 1. This is the connection between u and v. If this u is present in graph, if u dot count, sorry, graph of u dot count, and it is also containing, this graph is also containing v dot count, that means it is greater than 0, or simply you can say dot count. And also if there is a cycle, for that I will run a DFS from u to v and with a visited array. So every time for every edge I will do a DFS, for that I will initialize a visited array. Now if so, if I have the DFS is true, this DFS will be a boolean function. It will return true if there is a path from u to v. Now, if that is the case, we will return the edge, or else for our convenience return -1. And I am counting graph of u. Graph of u dot push back v. As this is an undirected graph, I will also push back u to v. In the DFS function, we'll start with u in v and also a vector of int visited. In this DFS function, we will go through every neighbor in for u. After that, for every neighbor, we will call for and we will return the neighbors DFS. U is equal to v. If u is equal to v, we will return true. And after that, even though if you traversed everything and you didn't get any true, then we will return false. I will start from here, check the neighbor and check here the neighbor. So here it is u, right? Here it is u, and imagine if this is our v, so here it will return u is equal to v, it will return true here. And if you can't find a v, then it will go everywhere and after that it will return -1. So this is how our DFS algorithm works. Now in the BFS algorithm, we'll be using a queue, right? Now I'll be not initializing this graph again for this BFS traverse. I will use in the redundant function. I'll start with every edge. Now in every edge, u as it is edge of 0 and v is equal to edge of 1, and after that we will search for BFS with u, and if you got this BFS, then return our edge, or else return -1. In the BFS function, we will start with int u and int v. Here there will be a visited array, and and there will be also a queue. Here in this queue I'll push back, in this queue I'll push back the first one u. Now after that, while this queue is not empty, while this queue till then I will run my BFS algorithm. I'll get the first node which is at the front, so the node will be front q dot front, and remove the first element or the node from the queue. Call for BFS with this node, and the target is V itself. Now, after that, we will return false if you didn't find any node or any. So here, if u is equal to V, then we return true. So this is how you solve this problem, and if you want a video on how you solve by using a disjoint set union, I'll give the link in the description. You can go and check it. So thank you, and if you like this video, share to your friends and subscribe to my channel.